Hello the internet and welcome back. Today on the bench I have something unusual, something that broke in my house, so I thought I'm curious to see whether by any chance I can fix it. It's a boost timer. I'm using it in my bathroom. I have a radiator which is running with hot water, but it also has an electric element in it. And by pressing this button I can basically set a timer of 15 minutes, half an hour, 1 hour, 2 hours while this electric element is running, so I can warm up the radiator with a towel on top for a set amount of time, and then it turns off automatically. Otherwise I would never remember to switch it off. Now this has failed and I think it can be disassembled, and I think I can see some components inside. Just wondering out of curiosity whether there's something obvious that can be fixed before I buy another one. So the way this works is very simple. You got mains in and mains out, and the mains out goes to the electric element, and then you just push this button. Once it would be 15 minutes, twice would be half an hour, another time it would be 1 hour, and then it would be 2 hours. And then I think there's a combination of push buttons where you can disable the current cycle or start again from scratch, that kind of stuff. It's a very simple thing. You just push it, like I usually push it twice for half an hour, and then after the half an hour it just switches off the power out of the output. Now here at the back I can see a relay. Obviously I can hear the relay clicking because this is up to 3 kilowatts, so it's pretty powerful for some heating element of that sort. I think my heating element is like 400 watts, so that's totally fine. I can hear the relay. I think this is a small capacitor, like a what's that, plastic film capacitor, that kind of stuff. And I'll show you in a second what it does. But basically what it is doing now, I can feel the relay. It's like clicking all the time, like it doesn't receive enough voltage to stay in a close position. I don't know, but it's definitely doing it without a load connected, so this is definitely faulty. And let me see if I can show you how it works. Alright, I got this wired through my isolation transformer just for a little extra safety, and don't do this at home of course. It's a very, very short lead, but anyways, it should work. I've got live in and neutral in, I think. Yes, that's N in and that's L in. So if I turn it around and I turn it on in 3, 2, 1, go. So you got this blue light here, boost, and it seems to be working totally fine, but I think the moment I'm pushing boost, it starts misbehaving. Let me see if I can capture that on camera. So clearly there's something wrong with this thing, and that's it. I think this can be opened, which is kind of unusual for this type of devices. I was totally expecting this to be completely sealed and like disposable unit more or less. So let me get rid of the mains cables here, and let's see if by any chance there's something very, very obvious inside that we can maybe fix. Okay, this is now open, and I'm a bit surprised. You'll understand that in a minute. Now, first thing first, I'm not a massive expert when it comes to that. I'm not Big Clive, so I'm kind of guessing here, and I do appreciate all your comments down below to tell me, what I'm saying wrong and what I should have noticed, how this thing actually works. But we basically have neutral here coming in and out. They're basically linked together, so it doesn't really matter. And then we have live coming in here and coming out here after the relay. So the relay is switching live on and off, and that's expected. Now you can see here there's a big trace coming from live in, which is going to this big, I think it's an X1 or X2 capacitor. Now if I'm turning these around, and you can see that there is a small bridge rectifier here, which is getting neutral directly and is getting live from the trace that we saw on the other side, which is coming here on this via, and it's going through. This is a 1 mega ohm resistor. It does measure 1 mega ohm with the capacitor at the back, and then that goes straight into the bridge. So the bridge is getting 240 volts, which is what we're getting here in the UK. If the bridge is getting 240 volts, it should get like 340 volts out. That's how it works. 240 rectified DC, it should measure like 340, if I'm not mistaken. Now 340 is coming out here, and where it says yes is where the small electrolytic capacitor is. So yes, there is a capacitor there. I don't know what that no yes is. It's 100 microfarad, I think, 50 volts. So we're not expecting any more than 50 volts. And the only thing to limit the voltage here is this Zener diode, if I'm not mistaken. Now, there's plenty of, I think there are like current limiter resistors. First of all, this is a 1 mega ohm resistor, so that obviously is limiting the amount of current flowing to the bridge rectifier. And these resistors here at the back, I think they got something to do with more or less the same purpose, just limiting the voltage flowing through the circuit, so the Zener won't have too much to do. But still, we're talking about dropping 340 volts to, I think it's 24 volts, because the relay is rated 24 volts, and that would be kind of consistent with the capacitor, which is rated 50 volts. So from 340 to 24 volts, even at a very, very low current flowing through the circuit, that's quite a lot, I feel, for a small component. Maybe that's totally normal. It's just, if I don't know, I was expecting like a small transformer, some sort of better implementation, or maybe this is totally normal. As I said, I'm not a massive expert, so please do leave a comment down below. Now here I can see the trace coming, let's say, out or parallel with the power supply, and then that goes into a pin here of this IC, and I can't tell you what that IC is because the marking has been erased, which is another thing. I mean, I purchased this from reputable distribution of electronic equipment, electronic stuff here in the UK. This feels like AliExpress. Now, I appreciate that everything comes from China, and fair enough, but I expect to see this from AliExpress, not from like a reputable high street chain here in the UK. Anyways, there's a little clock here. It says 4. Is that going to be 4 megahertz? I don't know. There's another Zener diode. Well, anyways, this is then controlling the output of the, well, actually, this is actually controlling these little transistor here, which in turns controls the 24 volts coil of the relay itself. So yeah, I mean, I guess that IC has some sort of program inside. I have no idea. I don't see any passive component around here. So the capacitor is definitely only for supply. So I was expecting maybe there's a capacitor, it discharges, and depending on what kind of resistor you have set up, it lasts for like 2 hours, 4 hours, or whatever. But no, I think it's a complete digital control. This must be some sort of microcontroller, I guess. So the reason why this is not working, I mean, assuming the relay works, I tested all these resistors and they all look what the banding says. I hate the resistors banding, it's horrible. These are 100 ohm resistors, that's a 4.7 kilo ohm. This is a 1 mega ohm, and all these little SMD ones, which are, these are current limited resistors for the LEDs. We got the LEDs 1, 2, 3, 4 here for the lights at the front. So everything seems to be working. The Zener diode also reads something, but you know, it's only telling me that there is a junction inside, nothing more than that. Same this diode. Everything seems to be like working when it comes to testing with the multimeter. What I'd like to test now is a few things. Now, first of all, I think I'd like to have a look at that Zener diode under the microscope, because it looks a bit toasty, maybe broken, I don't know, maybe it's just me, but I'd like to have a look under the microscope. Then I'd like to see what kind of voltage we got out of this bridge rectifier, just out of curiosity. And then we'll move from there. I have a feeling that the moment the relay is energized, the main voltage is dropping for whatever reason. Maybe the diode has, the Zener diode has failed, maybe the capacitor has failed. The capacitor is Chinesium. It's Huahong. So it's clearly a very, I mean, this is 20 pounds, so it's not expensive. I'm not expecting anything too fancy from something like this. But yeah, let's start with measuring what kind of voltage we are getting out of that bridge rectifier, which is then obviously regulated by the Zener diode and smoothened by the capacitor. Alright, I've soldered a couple of leads on the bridge rectifier output. Hopefully nothing horrible is gonna happen, and I've got my fluke set to, oh, we got some voltage. Well, I guess it's the voltage coming from the fluke going into the capacitor, and then it now is coming back. Let's turn it on. I'm expecting something around 24 volts, I guess. 3, 2, 1, go. Yes, 27 volts. Okay, so that's what I was expecting. And obviously, the moment I'm turning this on, which now is going to be pretty pretty dangerous to do, I'm hoping to see that voltage dropping, and that might explain our problem. Now, a weird thing is that those two buttons, they're labeled switch 1 and switch 2, but there's only one button at the front, so it's pushing on both. I don't know why you need two buttons, but anyways, let me try. I got this piece of plastic here, and I'm gonna try and push this thing. This is going through my current limiter, so anything can happen. It's very, very low current that can flow in a short to this circuit here, so I'm kind of not too concerned about that. But let's try and turn on the contraption. Okay, so this is doing what it was doing before, and I don't know, I mean, unless my multimeter is not fast enough, I don't see a problem with the voltage, at least, let me turn this off, at least not at the bridge rectifier. So maybe that is not a problem, maybe there is a fault with the IC itself. Right, if you think I've discovered this little Zener diode here, I think it's delivering 5 volts for this IC, because if I'm turning this on and I'm checking the voltage at the Zener diode, 3, 2, 1, go, we got 4.6, which I'm assuming it's okay. And this is coming, I think it's coming here. The IC itself, 3, 2, 1, go. We got 4.6 volts, kind of on the low side. So who knows, maybe that is the problem. And the other thing I've discovered is that the relay coil is getting 24 volts on one side, and this little transistor here is basically closing to ground, so to permit current flowing through the coil and activate the coil. Now, when this thing is misbehaving, I more or less still have 24 volts running. It's not as stable as when it's not doing anything, but it's kind of expected. This is a very low power thing, so I'm assuming the coil just trying to activate will cause a little bit of voltage drop. So I can measure 24 volts here, because from this trace here is going straight to the coil here. And if I turn it on now, I'm measuring 24.67. Again, it's a very simple circuit, so the voltage is barely regulated, but it's 25 volts. And if I activate this thing, this dangerous thing, I mean, the voltage is definitely being affected, so I'm not sure whether that is enough. But again, the relay is 24 volts, so it should work. And what I'm seeing is that this little transistor, which is again basically acting like it's a switch to activate the relay or not. Obviously, one side is the coil, the other here on the right-hand side, that's ground, I'm guessing. And here on the left, that's the control coming from the little IC. And if I'm scoping that control, actually I can scope before this resistor. I don't know why it's there, but it's definitely there. 3, 2, 1, go. I'm getting this mess. So this is kind of telling me that the issue might be coming from the IC itself. The IC is not, if I had found this transistor fully controlled and then something is misbehaving, then we have a problem with something else. But there is an issue with the control of the transistor. Unless, I think the relay works totally fine, unless this voltage instability that I see is enough to maybe stop the IC and it kind of resets all the time. Because the other thing is the IC kind of seems to be working. I'll show you why. Because if I turn it on, now you have one blue light flashing here. I'm not sure how much you can see that, but that's like the 15 minutes timer. Now if I push this button again, it should go to the 30 minutes timer. As you can see, it went to the 30 minutes. So it sounds like the IC is somehow working. It's definitely doing something, because it's getting the press of the button. It changes the time of the timer, but it's unable to control that coil there. Now let's see what the voltage going to the IC is doing when this whole thing is misbehaving. So turn it on, 3, 2, 1, go. I'm reading 4.5, previously was 4.6. Is that enough to reset the whole thing? I don't know. 4.5, it's kind of a low side, so I'm just wondering, I mean, there's really not much I can do here. I want to have a look at that Zener diode under the microscope, to be honest. But one thing I can try is to swap that capacitor. I know it's like the simple thing. I mean, if the capacitor is bad, I guess it might be unable to keep a reasonably smooth voltage going to everywhere, because that voltage then goes to the relay, it goes to the transistor via the Zener diode, even though the Zener diode then dropping from 24 to 5, so it doesn't matter how bad that 24 volts is, because the Zener diode then will make sure that it's perfectly stable. But it's definitely something I can try, and then obviously, I don't want to invest money into this one. It's more an analysis of the fault. The capacitor is the the simplest thing I can do. Another thing I've discovered is that this resistor here, this 1 mega ohm resistor, is actually the one dropping AC voltage from 250 volts that I'm getting here out of my isolation transformer to 29 volts AC. So, that makes things a bit more bearable. So the bridge rectifier there, it's only converting 29 volts to 24 volts DC. So obviously, that Zener diode is actually doing a reasonable amount of work. Again, still wondering whether is that expected to get like main voltage drop down to 30 volts via one resistor, which is in parallel with an X1 capacitor. I don't know, is that like the good thing to do when you need low voltage on a device like this? Do leave a comment down below, because honestly, I don't know. So I doubt that is our issue, but I would say let's swap that small capacitor and see if by any chance that's the one making that kind of instability, which is then causing that problem. Here is the Zener diode, the first one, Z1, and yeah, I can see some, I don't know, some black stuff inside. Is that supposed to be like that? I don't know. But I can compare with the one on the other side, which is looking after the 5 volts for the IC. And you can see that this looks totally clean. So I'm not sure whether that suggests that the other Zener has been, kind of abused a bit, and over time is not too happy. But again, we are reading more or less the right voltage, even though, yeah, it is dropping a bit. So maybe that is not the problem. Well, maybe we found our problem. This is a 100 microfarad capacitor. It's reading 25. Most importantly, ESR is reading 140 ohms. I know that this component tester is reading 0.14 kilo ohm when it's the end of the scale. So the capacitor is short, and maybe that's our problem. Well, it's definitely gone, so let's replace it. That might fix it. I haven't got a 100 microfarad at 50 volts, I only have 35 volts. I only have a 220 microfarad 50 volts. Now, these being a smoothing capacitor on a simple circuit like that, I think it's going to be totally fine. Let's install this one as a test, and then I'll decide what to do, whether I want to just get another one or just get a proper 50 volts capacitor. Alright, time to test. The fluke is connected to the output of the bridge rectifier, so obviously the capacitor is paralleled with that output. I'm assuming we're going to see more or less the same voltage, but then we're going to see whether it's working or not. Let's give it a go. 3, 2, 1, go. Okay, we got 28. I think earlier on we only had like 25 or something. Obviously, with an oscilloscope, probably we would have seen a massive ripple on the output. But most importantly, let's see if it works. Now it's in standby. I need to push this button once. It's working. Look at that. Got one LED turned on, which you might be able to see that or not. It's a bit kind of overexposed, and yeah, I can go up to whatever, and then if I push it again, I think it resets itself. Yes, it's totally working. It was the usual capacitor, which is kind of weird. I mean, I don't use this too much. Clearly, the capacitor installed in this machine is like of the most awful quality, as the brand can say, of course. And well, I guess we just saved this little thing from recycling. So I got the thermal camera out, and yes, as I kind of suspected, the main Xeno diode is working a lot, is running at 95 degrees all the time. And this is running 95 degrees not just when the the towel is being warmed up, but every time there is mains. So this is constantly running 24/7 at 95 degrees. And obviously the capacitor, it's exactly on the other side. So I'm assuming that over time the enclosure, is just keeping the heat in there, and I'm assuming that the capacitor and also those two bigger resistors, 100 ohm bigger resistors, which are sitting by the capacitor, they're nowhere near where the Zener is, but you can imagine you got the Zener underneath at 95 degrees, the resistors on the side at 60 degrees, the capacitor, which is not the greatest quality, and it's only rated 85 degrees, and you can imagine that these, after 3 years, which is the time that this device lasted, obviously the capacitor failed. Actually, now I'm looking at the capacitor. The capacitor actually says it's rated 105 degrees, which is impressive. I'm assuming it's just rubbish. It's just a random number printed on the side of the capacitor. But anyways, it's kind of expected. Even a good capacitor would have trouble surviving so many years in such a hot environment. I guess the reason why the IC was still working is that the IC is installed after a further Xeno diode, and the other Xeno diode doesn't care if the input is all rippled. He will just stabilize it to a lower voltage, and from 20 something volts to 5 volts, that's quite a lot. So unless it's massively rippled, the Zener can probably smoothen it like a capacitor. But obviously the relay didn't like that thing. It was massively rippled, and yeah, obviously the relay didn't like that kind of AC voltage basically coming to it, or partially only rectified voltage, no smoothened voltage coming to the coil. So what can I say? I hope you enjoyed this very small video. I thought, I'm gonna open it up, I'm gonna do it on camera. If it turns out to be something interesting, I'll make a video out of it. If not, I'll just discard it. I think this can be interesting. I hope this has ended up being like a shortish video. It's kind of interesting as it's the usual capacitor, but it's nice to see what was happening on the circuit and find a solution rather than just say, let's swap the capacitor and see what happens. At least we had a look at the circuit and how it operates. I'm really, really curious to hear from you. What do you think about this thing? Is this safe? Is this how it should be? Is it normal to go to a high street, reasonable and reputable shop in the UK, buy something and find like the erased chip in it and all this sort of, I don't know, kind of sketchy design from my point of view? This is totally my opinion. Let me know down below in the comments. I'm really curious because I don't really know, if I was asked to make something like this, I wouldn't know where to start. So I'm not in a position where I can say this is right, this is wrong. So if you know something, do leave me a comment. Consider subscribing to this channel if you like this kind of things. Don't forget, this is my second channel, so you will find hopefully some more interesting thing on my main channel, Tony359. Thank you very much to all my patrons, and do consider subscribing to my Patreon if you feel like supporting my work. There is a free tier, so no excuses. If you don't want to join Patreon, I understand. You can buy me a coffee. Link is down below. If you don't want to buy me a coffee, maybe a like, a comment, a subscription if you really want. But in any case, do appreciate your time, and I hope you enjoyed this video. So that's it for today. I thank you for watching. Hope you have a great day, and see you soon on my next videos on my channels. Thank you very much, and goodbye. Bye-bye.